All right. So we are still on the first chapter in networking, where I have started my lectures on the network and data communication before the break. Last week was the break, and it's a long list of slides. I'm not going to go through every slide again, but I'm just running through slowly just to refresh you and me so we are aware what we have covered 2 weeks ago. Yeah, so maybe some of you have done the revision, some of you have not because you have other subject as well to cover during this period of time. So I'll run through slowly. If you have any question or require any further clarification, stop me at any one of this particular slide. Otherwise, I'll run through slowly and then we will move into the continuous next slide. So we did cover on packets, channel characteristic, multi-link channel, network topology, logical and physical. We covered the basic network topology, mesh, bus, star, ring, hybrid, which is mesh. Then we go through one by one in quite detail. Started with bus topology, bus in network implementation, star. Additional point that you need to know is the advantage and disadvantage of each topology. Some of the points are on the slide. Some points are not there. So you need to know, yeah? Ring, mesh, 5-node full mesh network, hybrid, hybrid. This is a ring plus star. Physical versus logical. I told you physical is the interconnected actual cable and wires, which is referring to the actual implemented network structure, whereas logical is like a blueprint on your paper or in your screen, in your system, not yet implemented, virtually designed and planned. Logical bus topology, connecting endpoints through links and network, example. Then we talk about local area network. What is local area network? Most of this stuff are very basic, which you have covered in your CIT, DIT, yeah, in your diploma level. Just a refresh for you. So you need to know all the basic, basic details about introduction to networking. Basic Wi-Fi, Ethernet. Remember, I told you guys, make sure you know what are the differences between Ethernet and Internet. Yeah, don't get confused. Backbone network, example of backbone, the client server version with all the network devices. We did discuss about metropolitan area network, which covers MAN, M-A-N, may consist of number of LAN, local area network. An example of MAN. If the question asks, there was one question in one of the exam paper asking you to draw and define how is the MAN, metropolitan area network, between two sites. They will give you two sites and you need to design such a diagram using all the proper cable link or connectivity with proper network devices, yeah, and you have to design this whole metropolitan area network, like what you see now. It's connecting three sites. with proper network devices and communicating channel. Wide area network is even larger, bigger than the MAN. We did discuss all the network devices. We get started with some simple devices as of 2 weeks ago. Then we continue our discussion with repeaters and hubs. I did explain to you what are the limitations of the hubs or repeaters, how hubs and repeaters have been so-called wiped out or replaced by a better device which we have today, which is known as a switch. And also I did share with all of you the differences, the main differences between hub and switch. Again, I'll cover that today, don't worry. But prior to that, we did talk about hubs and network bandwidth such as half duplex, simplex, and duplex. You have to recall whatever you have covered in your data communication and network in your diploma level or previous programs. Ethernet switch, switches. Later we move our discussion into switches, which is at layer 2 of your OSI, Open System Interconnection diagram based on ISO, International Standard Organization. Switches and network bandwidth. Switches, as you know, it works at full duplex, 2 ways. And then this slide here, we talk about hub versus switch. Yeah. And again, I will explain to you, I will share with you what are the main differences between hub and switch. Okay, before we go into wireless access point, let's discuss about hub, and then I'll also will explain to you about switch before we go and compare. Before the break, I told you the bandwidth in the hub will be shared among all the users. For example, if user A send a message to someone in the network, the way hub works, everybody, the sender, yeah, or the message from the destination, from the source, will broadcast to all the ports in the hub. And whoever the receiver is will receive the message. But the sender will broadcast to all the ports in the hub. That's how hub works. Because hub is a passive device, non-configurable. Yeah, non-configurable. Because you buy a hub, you plug and play. That's it. You on, you plug all your cable, it will work. You don't have to, or it doesn't require any setting or configuration. Whereas switch is different. Switch, you cannot just on and start using it. It won't work. Switch require configuration. So switch is active device, smarter device, require configuration before you can start using it. Other differences are normally hub are very much cheaper than switch. The way switch works is completely different from hub. In switch, you don't share the bandwidth. Everyone is dedicated. Yeah. If the switch is 100 Mbps, everybody will get 100. Meaning if the port is set 100, every single port will be set at 100. So if you're sending your message at 100 Mbps, everybody will get it at 100. In hub, if the hub is 100 Mbps, if there are 2 users, the bandwidth will be shared among the 2. So both of them will get 50-50. But in switch, it doesn't work in that way. Yeah? Switch is dedicated because it's smarter, configurable, Everybody will get, if it is 100, you will get 100. That's the main difference between hub and switch. Okay, next we have wireless access point. This is what we call Wi-Fi sometimes, or access point, AP. In switch and hub, so far we use wired. It's connected, physically connected. But wireless or AP or access point is definitely Wi-Fi, Wi-Fi. It also runs on Ethernet technology, but the technology is different from the wired. Different Ethernet. If you look at all the numbers start with 802 point something. The point something will make the difference, whether it is wired or wireless. The way AP works is same as switch, but not as fast as switch because it is wireless. Normally it is very much lower, very much slower to compare to wired switch. If wired switch you set 100, you will get 100 Mbps. Switch sometimes you get only 70 Mbps or even lower. You see some of the switch, the older version works at 11 Mbps only. But the new switches, new AP that we have today can work up to 70 or even more. The more you pay, the higher the configuration or the setting, the switch or the AP works better, right? And I also would like to share who are the manufacturers of all these network devices. Number one, almost number one in the world is Cisco. Then we have Huawei, we have HP, we have some other players as well, smaller players like 3M, 3Com, and few other players. There are quite a number of other smaller players. But when it comes to switches, routers, where these devices are very much critical devices compared to hub or AP, normally the branded one are better, like 3Com or Cisco or Huawei. Those are good branded. Why we pay more for this type of network devices? For very simple reason. The more you pay, it comes with reliability. Like Cisco, the uptime is 99.999%, which is very high. 99.99939, maybe your downtime will be 1 hour in a year. That's very good, isn't it? Maybe when you go for a holiday, you can switch down or you can off your switch for maintenance. Other than that, the switch will be up and running without any issue. But if you buy unknown brand, normally they will give you the uptime 99%. 99 means 1% is a downtime. 1% out of the 365 days, it can be, a few hours, which is not good. Just imagine your network is down for a few hours, that is not good. That's the reason why those who are working as a network engineer, your critical KPI, key performance indicator is uptime. KPI, uptime, meaning you need to have better uptime. Like in my case, when I was working in an industry, we always set 99.99. That is good enough. 99.99, it allows you to have 3 hours of downtime in a year. 3 hours of downtime is required, and normally the management will approve it because you need to do maintenance once in a year. So normally we will take advantage. Either we do maintenance during the Christmas because everybody will be away. IT guys got to work, and normally we will take 1 or 2 days to do all the maintenance during the Christmas. And then after that we will disappear, for the new year, which is a good time. So 3 hours is what we require in a year to do maintenance. Other times it's very difficult to do maintenance in Malaysia because during Raya or Deepavali or Chinese New Year, normally everything will be up and running. You cannot go and down your system because people are still working, banking are still operating as usual. So you cannot down. But during Christmas, the foreigners, American, most of them will be out as well for holidays. So normally they will approve your maintenance. That's why we need at least 3 hours per device to do the maintenance. Okay. All right. With that, I'm going to quickly check our connectivity. If there is any question, guys, any question so far before I continue?
No.
Okay. Try to ask some questions, even beyond the subject. It's okay. But must be related to network and operating system. Of course, I don't prefer to answer other questions, even though I can or I will try. But if there is any other question related to Wi-Fi or connectivity or network, bring it up. We can discuss here, or we can even take time to look for the solution. Because exam, even though it is an open book exam, normally will be tougher than the closed book exam because they can set any exam now, any questions, because it's an open book. Doesn't mean it will be simpler or as easy as closed book. So of course they will set some questions out of the syllabus or require some thinking or require some calculation or understanding of applicable application. So better be prepared for that. But don't worry, we will go through two versions of or two classes of revision or at least two papers. Okay, if no question, let me continue with the packet routing. Okay, what is packet routing? Packet routing, when you talk about packet routing, packet is the data which we transmit in a packet format, in a packet. Like you pack it and you send. Like how your Grab driver, delivery boy, or Lalamove pack your food and deliver to you. So data also will be packed in a packet and will be sent from the sender to the receiver. But this data or this packet, which comes with a lot of details, can be sent in many different ways. Same like the option that you have, you can send through Grab delivery boys or Lalamove, or now we have AirAsia, all kind of moves, DHL, all kind of movers out there to support you. It's up to you who you prefer, or sometimes the uh, selection criteria is based on pricing, cost, and quality of service. You see, when I say quality, QoS, quality of service is very important for networking. So we have an option. What are the options in networking? One is what we call circuit switching. Circuit switching, you have to pay more because they dedicate a channel between the source and destination for duration of connection. An example, a very simple example of circuit switching is like Astro in your house. Astro in your house, there is a dedicated connection between your house and Astro. How you do that? Through the dish that you have on top of your house, the dish uh, which is referring or pointing to the satellite, to the Maxis or Binariang satellite. That is a dedicated switch. So in a month, they charge you by monthly, isn't it? Not by hours or not by usage. You use it, or you don't use it, you pay a fixed amount every month. So dedicated connection only for you. Nobody else can hack or nobody else can use it. Only for your house. The device at your house recognize it and you use it. That's how it works. Last time, the technology was quite old, where when you go home to your village, like Bali Kampung, you take your card and you can go home to your kampung and you use your card. That was, once upon a time. Then Astro learn about it, they change. They stop that as well. They change the card, they change the device to avoid all that because, as usual, they want to make more money. But that is an example of circuit switching. Or another example is when you pick up your landline, house phone, you dial a number, and then once you get connected, that is also circuit switching. There is a dedicated switch physically connected end to end. That is circuit switching. Then the other type of packet routing is what we call virtual circuit. Virtual circuit can be multi-link channel. Yeah, this is exactly when you communicate using your internet, like your WhatsApp connection or your Twitter connection or your YouTube or your Skype or your Zoom. Anything that you use on your internet is not dedicated because you're using public channel, which is also being shared by many others. That is what we call multi-link channel. For example, let's say you use your Google search to look for information. The search can happen from your house, goes through Singapore to US, or it can go through Hong Kong to US, or any other channel, Bangkok to US. How or how the system decide which route or which channel to use? There are some criteria. There are some criteria. One of the criteria that I can share is it depends on the traffic. If the traffic between Singapore and US is very high, of course, that channel will not be used. The system will try to use less traffic channel. That's how it works. Very simple. Yeah. So the Google search has a mechanism. It checks the traffic. If the traffic is too high, based on some detailed calculation, it will avoid that channel. It will try to look for a less congested channel. There is a mechanism built in the software, which channel to use. So that is what we call virtual circuit. And one common term that which is familiar for virtual circuit is VPN, virtual private network. Virtual private network is more dedicated, uh, quite close to circuit switching, but again it is virtual, using internet. But sometimes the VPN is not free. You have to pay for it, yeah, or you have to buy license compared to internet, which is almost free, or it is parked under a package. Like your WhatsApp is almost free, even though you pay a very small fees yearly basis without you knowing it, but they charge to your service provider, which you don't even know, right? Okay, then we have what we call packet switching. This packet switching, like I mentioned earlier, it can be either through the circuit switching channel or virtual circuit channel. Each packet, like what I mentioned earlier, the data will be packed as a packet and will be routed from node to node, like one node through Singapore, the other node through Bangkok, the other node through Australia, for example. End of the day, all the node will be combined. Yeah, all the node will be combined together. Let's take a small visual understanding over here. You have part 1 and part 2 over here in this first diagram. A to B, A is the sender, B is the receiver. So you have, you see, multiple channel. An end-to-end channel with many possible parts through intermediate nodes. There are options, isn't it? Part 1, part 2, part 3. This is what we call virtual packet switching. Virtual. Virtual circuit in a network, it can be even more complicated than that. Yeah, than the first diagram. The second diagram is even more complicated. You see, you have A, E, F. You can follow many routes to go to B. And there are many apps that we have today works on this. For example, your GPS, Waze, also works on this technology. Your Google Map works on this technology. And there are many other apps works on this technology. It checks for traffic light, it checks for traffic, it checks for accidents. Normally, the apps are designed to avoid any, very simple, any congestion, so that you can reach your destination faster. Faster doesn't mean safer, but faster. That's how the system works. So your apps have been built in with mechanism or calculation or formula which helps you to reroute or calculate immediately, almost real time. Even though it is not real time, it's online, but almost real time, to get you the paths available so that you can reach your destination. Guys, if you have any questions, stop me, because not much of detail to discuss about this packet switching. More details have been covered in your diploma level. Next, what I'm going to cover is routers and gateways. Another complicated or advanced device in network devices or network equipment, which is a router. Router works at layer 3, network layer. Layer 3 is network layer. Layer 1 is physical layer. Layer 2 is data link layer. Layer 3 is network. Specialized devices used to interconnect network and pass packets from one network to another. Yeah, so when packet is arrived at one input port, the processor inside the network or inside the router decide where is the packet to be delivered or to be directed. So the router even more advanced than the switch. The packet has what we call routing list. Who are the user, who is sending, where you're supposed to send, or who are the receivers. All the details are available in the routing, in the routers, in the routing table. Then the router just need to take a look at the routing table and route the message accordingly. So router is even higher or smarter than switch, requires a lot of configuration. So normally you need to go for training, maybe 5 days training for your switch, another 5 days training for your router under Cisco. So when I did that, I went through 5 days of training for switch, and I went through another 5 days of training for routers. So that's how I went through my trainings. So it is a very complicated setting, routing, and a lot of details need to be covered. And you got to be very good at networking, like items like IP addresses, calculation, protocols, and so on. Okay, so there are different devices for routers and switches, and then the settings are different as well, because the function of these devices are very specific compared to the earlier device, compared to hubs, compared to repeaters, compared to switch, compared to any other devices in the network. So your network actually has many devices, So when you draw the diagram, make sure you make use of all these devices inside your network diagram. There is one subject in the final year, which is network technology. You guys will be covering a lot more detail in that subject, because in today's world, even you want to become a software engineer or programmer, without good understanding on network, how the network works, how the data is being transmitted, what is protocol, even security. Without knowing all these details, you cannot be a good programmer. It's like a handicap. So you need to have a very good knowledge on all these areas, including operating system, before you can become a very good programmer. That's the reason why UOG has blended your entire program with all these subjects, so that it prepares you to become a world-class or high standard software engineer. Okay, the next device that I'm going to cover before we take a short break, it's almost going to be 4 o'clock, is gateways. Gateways is also another device, another network device, same as router, but the function is completely different. Gateway is the device that we use to connect the router to the outer world, to the outside world. Gateway is the device where you connect your internal network to the outside world, to the internet world. There will be an area what we call public area, secured area, and then your internal network is protected beyond the firewall, and then outside the firewall is what we call public areas or the internet, which you will see not protected, all kind of viruses, everything will be there. But beyond the firewall, which is your network, is highly protected by the firewall, as well as routers and other devices. And we don't want to have too many gateways or channels linking to the public network, because it is very dirty. It's not protected. It's not secure, right? So to keep your network secure, protected, you will make sure all your routers are connected to the gateway, and then gateway is the only channel for you to go to the outside world. So the channel that is connecting the outside world and your network, the device is what is known as gateway. Yeah, gateway. Okay, this is router block diagram. Router, this is router. So the switch is like inside the router. Then you have a lot of NIC card network port. Very simple, high level router block. And slightly better picture of routers is where it connects LAN together to create an internetwork. Internetwork means slightly bigger network. You may have a few smaller LAN. So you can see a small business there connecting to ISP. Then you have an internet router. Yeah, one or two or three back up each other's or covering different areas, different floors. Then you have your server, internet server. So this is server, this is client. So this is how it works. For example, you are at home now, you use Wi-Fi or you use wired, connect to your hub or switch through your ISP, isn't it? For example, Unify or Maxis or DG or whoever you call it. And then your ISP will have connection, number of internet router, which is connecting the international network connection, US, mainly US, because most of the information are coming from US. or Singapore or Bangkok, Thailand. And then in US, we have all the servers, or in Singapore, we have all the servers, or in Thailand or in Taiwan, we don't know. So once the information is available, boom, it will download back to your home. So that is the function of the router, to route the traffic or your request accordingly. If you search for information from US, it has to be routed to US. Unless the information is available in the server which we have in Malaysia, it will download it from the information from the Malaysia server. But if this information is not available in the Malaysian server, then he has to go and look for the next level, which could be Bangkok, for example. Let's say the information is also not available in Bangkok, then the search got to go through to US. Okay, router versus switches. Before we take a break, let me go through that. Router connect lines, switches create lines by connecting computers. So switches create the LAN, part of the LAN. So once the lines are available, router connect all the LAN and connect to the gateway and connect to the internet. Router work with logical IP addresses. Switches work with physical MAC addresses. Remember, router works with logical IP addresses. Switch works at physical MAC addresses. These are the differences between router and switches. So this kind of slide will be a favorite slide for the examiner to set question. So you got to pay attention. Router work with packet, switches work with frames. Router don't forward broadcast, switches do. Router use routing tables, switches use switching tables. So you need to know all these differences. There are 5 points there. Easily you can get 10 marks. Remember two things. One, you need to know the differences between the router and switches. Second, you need to know the differences between switches and hubs. These are two favorite questions I have seen the examiner used to set. All right, before go to the next slide, the time is 3:55. Let's take a 10 minutes break. Come back at 4:05 and we will continue with our sessions. Yeah, take a short break. Unless you guys got any question, you ask me now. Otherwise, we take a 10 minutes break.
Sir.
Yes.
About the submarine cables, sir. Do they fall under virtual circuit or packet switching?
It is a physical or physically connected cable or channel. So it is circuit switching, not virtual, physical.
Oh, okay.
We have under the sea cable connecting Peninsula Malaysia and Sabah Sarawak. Normally we use fiber optic, and the same goes to Malaysia connecting to US. We have a cable connecting. It doesn't go straight to US. It goes country by country. Maybe we are connected to Singapore. Singapore is connected to another country, and so on. But every countries have invested some amount of money to have this cable. In fact, I got to know that we have a direct cable, fiber optic cable connecting to US, and we call that dedicated circuit switching cable, or MPLS. The speed is not very high. It can be maybe just a few meg, because it is a very long distance cable, but very high reliability cable. We need to have that cable so that we can get the information immediately. When you search through the Google, for example, information about the latest news in US, that's how it comes in. And that is one. For example, when I work for US company, we have a dedicated MPLS line with US companies between the corporate network, not for the public, company to company. And I used to pay like 200 over 1,000 ringgit per year for that dedicated line. It is only 2 MAC line, 2 MAC, 2 Mbps line, dedicated 24 by 7, 24 by 7 by 365 days. So because of that, it's dedicated to your company. It is available 24 by 7. You have to pay that amount. Otherwise, like most of the companies are doing today, we are connected to the internet. So if the internet is down, you will be disconnected. So when you connect to the internet, we call that VPN, virtual private network. Not so dedicated, but yet it is available, but it depends on bandwidth. So if your network is very busy, for example, let's say there is a World Cup going on, everybody is watching football over the phone or laptop, then the bandwidth will be very busy, your connection will be very bad. But if you use MPLS dedicated under the sea cable, for example, then your connection is private, yeah, then you don't have to go through this bandwidth issue. That is the difference. So internet, you don't pay or you pay less to your ISP, but dedicated, you pay more because it is a dedicated line between your company in Malaysia and US. Thank you for the question. Any other question, guys?
No.
Okay, otherwise take a break, short break, 10 minutes. Okay, guys, let's continue. Let's continue with our lectures. Let me share my screen again. Okay, the session is being recorded. Recording is still running. Let me go back to my slide. All right, we continue with routers and switches. Okay, we look at the differences between routers and switches before we take the break. So router connects LANs. Switches create LANs by connecting computers. What is the difference? You use hub and switches, yeah, as network devices to connect or to make up your LANs, to build your LAN. So once your LAN is ready, you connect all the LAN using routers. So once all your routers are ready, you connect all your routers or one of your router to the gateway, yeah, to go out to the outside world. Your LAN is a private, only to your company. That is number one. Number two, routers, the way it works is it uses logical IP addresses. That means you only configure inside the router. While switches work with physical MAC address. Switches will have actual connectivity with the other switches or hubs in the network. So switches will have many ports that are connected to other lines or other switches or other hubs. And also switches will be connected to the routers. Routers will have only a few ports, high-end ports, high-speed ports to connect between the switches and routers. And when you configure the switches, you also need to configure the port. Each port connect to which switch or device. So it comes with MAC addresses of that particular device. For example, if you have a switch connect to an AP, the AP will have its own MAC addresses. If the switch connected to another switch, both the switches will have MAC address. As you all know, MAC address is unique. The device need to have a very unique MAC address, and there should be only one device in the whole world have one MAC address. It got to be unique. Otherwise, you will run into duplicate MAC address, which never happens. That's how the manufacturer understood it. It's the same sometime when we run into duplicate IP addresses. Yeah, but duplicate IP addresses is not serious as duplicate MAC addresses. Every device, when it is connected to the network, must have a unique MAC address. And then the other difference is router work with packet. Remember packet switching? At higher level, bigger packet. So it works on circuit or virtual or using multi-port or single dedicated channel. Where switches break down the packets into smaller portion, into smaller data, which we call frames, and it works at frames. Router works with packet so that it breaks down your entire message, entire data into few packet, and it can transfer, like what we discussed earlier, packet 1 maybe through Singapore, packet 2 through Bangkok, packet 3 through Hong Kong. So there are 3 packet, 1, 2, 3. When the receiver receive it, the receiver will rearrange the packet. Even though the receiver receive maybe packet 3 first, but it will wait for packet 1 and 2 to arrive, then it will put all the 3 packets together, rearrange it, reorganize it, resort it before display it to the user as one packet, as one complete packet. What happens if there is a missing packet? Because it works on on acknowledgement TCP/IP, so the packets will be retransmitted until all the data has been transmitted successfully. The receiver will put the packet together and display it to the user or send it to the user. That's why it is a very reliable transmission under TCP/IP. Router don't forward broadcast, switches do. Router, it doesn't broadcast, like switches or hubs, they broadcast the messages to all the ports. But routers are very dedicated, one switch to one switch or one router to another router, that's it. Very smart move, because normally router will carry a huge amount of data. You cannot go and broadcast. What happens if router broadcasts, the whole traffic will be busy and will go down, because the amount of data being transmitted at the router level is normally very high. It runs into hundreds or thousands of megabytes. So normally you don't allow to do broadcasting. But at the lower level, at the switches or at the hub level, yes, you can do that, because the amount of data may be into hundreds or tens or 20s of meg. That is manageable. But the router data at the router level, meaning let's say one router is in Penang, the other router is in Johor, the amount of data that being transmitted between these two sites can be very high. So you cannot go and broadcast to all the routers in Malaysia. Then the whole network will be very, very busy. That's why sometimes when you have a major event, for example, Merdeka Day or big celebration, sports, marathon, when you are in the crowd, you don't get a coverage like your phone coverage, because the network is being, is being shared and being broadcast, so will run into congestion. No more bandwidth to transmit the data to your device. So if you go away from the crowd to a very individual spot, then you will receive it because of the bandwidth, because of the bandwidth. Routers use routing table, switches use switching table. Inside these devices, inside these smart network devices, everything controlled by software. What we have is a table, again is a virtual table, logical table, where every IP address, every MAC address, every username, most of the information that you see in your task manager will be kept in this routing table, so that the routing table can be used to send and receive data accordingly. Because the users on the network doesn't control the users on the network. The users on the network can come to the network at any time and leave the network at any time. For example, let's say if we refer to cyber cafe, you have users in and out from the cyber cafe every minute. So the router need to update this routing table every 60 seconds. That's how router works. Router will like route and check who are on the network and who are not on the network every 60 seconds. Yeah, and then it will update the routing table. So the router is like almost real time, is aware of who is on the network right now and who is not. Switches does the same, but switches does at very smaller broadcast or smaller range compared to routers, because many LANs will be connected to the routers, but fewer LANs will be connected to switches. Now, that is the difference. So try to understand these statements, and you can easily write about another 4 to 5 points under this each major point in order to collect your full points or full marks. Don't just write one line and then you stop. You must explain, you must elaborate and explain what it means. And another way of good method of answering question is by giving examples. Not necessarily IT examples. Sometimes if you really run out of IT example, you can even use examples like what I did earlier. When there is an event, what happened to the network bandwidth? When there is a security breach, for example, what happens to the network? Or when there is a too much of downloading, what happened to the network? Or when there is a live broadcast, football, World Cup, what happened to the internet and how the internet affect all the users in that particular areas or in that particular country, for example. So you can use any example to explain your answers. And the good thing when you use examples is when you use example to explain, and if your example is correct, it shows that you understand the question or the situation better. That's the whole idea. So please always provide examples. All right, so you have two diagrams at the bottom. One is more to a switch, the other one is more to a router. Please take a look. Okay, standard organization. When it comes to standard organization, there are many, such as ISO, International Standard Organization, or International Organization for Standard. This is an organization which control all the standard in all countries. There are 17,000 standards or more in the world today. So whoever is planning to produce some product and then you want to market it at the global level, you must get their recognition. If you don't get their recognition, nobody will buy your product. In other words, you cannot sell it at the global level. For example, Cisco products are at global level. Everybody knows Cisco. So any product produced or manufactured by Cisco will be accepted immediately because they are part of the ISO, Huawei, what else? Motorola, HP, IBM. Those are the companies where they have got their certification from the ISO. And the reference model that they use is OSI. I believe all of you have covered this model during your diploma level, open system interconnection. Like for IT or communication model, there are 7 layers that you need to remember, starting from physical layer, data layer, network layer, and so on. Then we have another standard organization. All these are not for your exam, but just for your general knowledge. IEEE, IEEE, Institute for Electrical and Electronic Engineers. This is very recognized institute in the whole world for many of the IT product that we have today. For example, the Ethernet standard 802.3, Wi-Fi standard 802.11, Bluetooth 0.15, WiMAX, which is available only in Klang Valley 0.16. Then connectivity with the satellite, connectivity between the devices, short range, for example, Bluetooth, infrared, RFID, all controlled by them. IEEE. They are the one come out with this technology, and they control using this standard, what we call Ethernet standard, not internet, Ethernet. So the numbers 802 point something is very important for all of you. You don't have to memorize this for exam, but for your general knowledge. You see, Bluetooth uses different standard, Wi-Fi uses different standard, the Ethernet wired, the physical. It started with 0.1, 0.2, and now 0.3. More advanced Ethernet connection. It also depends on the cable. Remember during the class, I'm not very sure about Penang and Subang. I do highlight that we have Cat 3, Cat 5, 5E, Cat 6, different UTP cable or STP cable runs or manufactured on different standard. The higher the category, the better the performance of the cable, UTP cable, or we call it internet cable or network cable. The other standard organization is IETF. This is more for engineering task force, not as popular as IEEE or ISO, but they are more for requests for commands, RFC. When there is a new product, you need to request for commands or request for numbers, is controlled by them, IETF. Then ICANN, Internet Cooperation for Assigned Names and Numbers, is more to IP addresses. Yeah, more controlling on the IP addresses, protocol, the domain name, protocol parameter, and so on. And also IANA, Internet Assigned Numbers Authority. They all more to Internet and protocols. Just for your information, not for the exam. How to connect to Internet? I think I don't have to go through this with you. You guys are expert in this. Further reading. Okay, that's the end of this chapter. Introduction to network. Any question before I switch over to another topic? Any question?
So far, no.
Okay, good. It's all very basic. I hope all of you can absorb this. So let me switch to another topic. Yeah, let me go back to Blackboard. The next topic will be Ethernet and TCP/IP. Okay, let me continue. So we were talking about end-to-end channel connection earlier, where you have two host computers or two servers connecting using some kind of channel or link. And in the host computers on both sides, you can see all the layers, network layers. The OSI 7 layers, not in detail, but at very high level. You have application software at the top, where you're trying to send a message using your WhatsApp, for example. This is your WhatsApp. You're sending a message, it goes to the network software, network layer, it goes to through the network card. You see your messages have been broken down into packet. Packet will be broken down into frame, and then it will be transferred through the routers and switches, all inside this connectivity to the other side. So the NIC card on the other side of the server will receive all the packet, frame into packet, packet into messages. Before you can read it on this WhatsApp message, for example. So it repeats all the time, the same things, repeat again and again. So that's what we call communication model. So the host to a client or client server or server client is an example of the communication model, that you can draw this kind of diagram. Depend on the marks. If they give you very high marks, go into very detail. You can talk about VPN, you can talk about virtual circuit, or you can talk about a dedicated circuit, like what we discussed earlier. It depends on the situation, and how detailed to go, how much to answer is again depends on marks given. If mark given is very high, 25, 30, make sure you go into very detailed. If mark given is 5 or 8 or 10, maybe you can limit your answers. Don't have to go into very detail. Simplified model of layered communication. What you need to understand here is you have a message, like I mentioned earlier, broken down into packet, into frames, into bits, and then transmit over. This is pretty standard. Happens on both sides, at the server level right to the network. TCP/IP, which you guys are quite familiar by now. You have covered this in diploma level. Make sure you know all the layers. Physical layer, layer 2 data link layer, layer 3 network, layer 4 transport, application. Then we have session layers and presentation layers, 7 layers. This is only 5. And remember, the different protocol at different layers. This is good to remember. Not a must, but good to know which protocol is being applied at which layer. That is good to know. Like, for example, TCP/IP. The protocol TCP/IP is layer 4. IP is layer 3. Yeah, DHCP layer 3. Addressing resolution protocol, ARP layer 3. Yeah, things like that. So try to understand and memorize it so that you know. For people talk about POP3, POP3 is at application layer for all the internet email. DNS layer 5, FTP layer 5, SSH layer 5, things like that. It's good to know so that when we talk about protocol, we know exactly at which layer the protocol is running. Then we have another model other than the OSI 7 layers, which we call TCP/IP model, which we have covered this in the diploma levels. Slightly simplified model. There are only 5 layers here. Start from physical layer, data link, layer 2, layer 3 network, layer 4 transport, and then layer 5 application layer. What is the difference here? Here there are only 5 layers. In OSI there are 7 layers. Other differences are more or less the same. The data at the physical layer will be in 1 and 0. Data link layer in frames. Remember, data link layer, your switches and your hubs are here. Network layer, your routers at layer 3. And then your switches also can be at layer 3, but normally switches will be a layer 2. Transport layer, the data will be in a segment format. And application layer, the data will be in data format. Yeah, so the data, for example, the message in your WhatsApp will be broken down into segment, will be broken down further into packet, will be broken down further into more details by frames before being transmitted into bits. Yeah, and carried over the physical cable or through Wi-Fi to the receiver. That's how this TCP/IP model works with 5 layers compared to OSI layers, 7 layers. There are 2 more layers, session and application. Presentation. Okay, so here you can see how it works. I just mentioned to you how it works. So it goes this way all the way and vice versa. Okay, what it means by encapsulation and decapsulation. Remember I told you packet comes with a lot of information. What you have here is data. Data without the information is useless because you don't know where to send. For example, you have a message, but you don't know who to send, then the message becomes useless. So you need to know who is the receiver. What it means by receiver, you need to know their phone number. So the phone number is what you need to send your message. Very simple. So in this case, it's the same. You need to know who is the receiver, IP address of the receiver, which network or which country the receiver is, and so on. So all that information will go into what we call header. There will be one header or more than one header. So all that information like the IP address, who is the sender, who is the receiver, how big is the message, which country, when to send, what to send, all the details will be kept in the header. The lower the layer, there will be more information being kept. So that when the information is being sent, the data link layer knows exactly which port or who is the receiver. Otherwise, when Astro just transmit everything, they just broadcast. They don't care who are the receiver. But you as a receiver, you have paid to Astro and they have given you a smart card that you insert the smart card into the device. Only then you receive the broadcast. Otherwise, you don't. So what it tells you is inside your box, whatever box you call it, now they have a few types of box. All the header informations are inside the box, and your card might keep the smart card. Astro card might keep some information as well. So when all the information matches, then your TV able to capture the messages. Otherwise, you simply buy a new TV and you wait for the Astro to come in. It won't work, isn't it? That's why you need to subscribe to Astro, pay for their service, then they will configure all the information, put the header, and put inside the card, and they give you a card with the device. Then your card and the device understand Astro packet, even though it comes through the air to your dish, but it is because remember I told you it is based on TCP/IP dedicated. So if it is dedicated for you, it will come to your house. It won't go anywhere. But anyway, for Astro, they don't care who is the receiver. They know. They still can see who are the receivers. That means when they run a program, for example, live football telecast, they know how many receivers are watching based on number, but they won't know exactly who is turned on and who is not until they see their detailed report. Immediately they won't know. They only know I have broadcasted, the whole world can reach it, or at a moment I have 100,000 viewers, but where are the 100,000 viewers? They have to check certain reports. Only then they will know. Otherwise, they know only numbers, 100,000 are watching now. That's why if you go to YouTube, if you go to YouTube normally will tell you how many are watching, especially live telecast. Normally, I watch news on YouTube. It will put that down there watching, and sometimes you can see the numbers. 20K people are watching. That means 20,000 people are watching the news. So who are the 20,000 people? The data is not there. You have to dig further because of this broadcast. So all the header that you can see in this slide now contain information such as sender information, receiver information, IP addresses, protocol, access level, and so on. Some of the information that you can find in your task manager. And then on your right hand side, also important for you to see the format of the data. At the application layer, remember earlier, the format of the data is in message format. Your transport layer, break it down into segment. Your network layer, break it down into datagram or frames. Yeah. And go further down, it will be in frames and bits. Okay. Again, the same TCP/IP model. So the next couple of slides, what they're going to do is they're going to explain to you one by one, layer by layer, what is function of physical layer and so on, which you guys have covered this in detail during your diploma level. So I'll try to run this in a quick format so we don't waste too much of time here, so that we can take a short break before we go and do our local tutors with your local lecturer. Physical layer, as you all know, which is the lowest layer in the OSI model, where it is actually the physical connection of your device to device, where you use cable to connect, or you use Wi-Fi to connect, or you use Bluetooth, RFID, or infrared to connect your two devices. The lowest layer in the OSI model, we call it physical layer. Yeah, physical layer. Then it's the same physical layers where the data is being transmitted in bits. There is a comparison between analog and digital data. You must know this, the difference between analog and digital. Now, hardly you can see your data is in analog format. All data today are in digital format. All the transmission through your phone is in digital. TV, smart TV, digital. Even your car dashboard today is all digital. Those days, everything analog. Now it's all digital. Simple link model. They just only want to share some terms with you. Rate. Actually, they're referring to bandwidth, capacity, and speed in bits per second. And if there is a delay in second. Delay normally relate to the longer the distance, the further the delay, or the longer the delay. So what we do, normally we put a repeater in between to make it faster, to to boost your message again. TCP/IP model layer 2, data link layer, layer 2, where the switch is, such as software logical link control, hardware medium access control, MAC. Medium access control is MAC. All are at layer 2, data link layer. And the format of the Ethernet frame, remember there is a header, isn't it? The header, what is inside the header is what you see now. Remember this diagram? You see a header there, remember? A lot of headers here. What is inside the header here, this frame here, is what you see here, into more detail. There are a lot of information inside the header, such as the start frame, destination address, source address, data length, data itself, and the CRC, cyclic redundancy check, whether you receive all the data successfully or there are some errors, all will be kept inside here. So inside the header, you have a lot of data, and this is required. Otherwise, you will not be able, or the network will not be able to send and receive information correctly. It has a lot more data. It's in fact a lot more detail than what you see. When you do this subject at different level, you go into different detail. Okay. Hub based in the Ethernet. Hub is even lower or simpler than the switch. Normally, hub will be used for bus network, as we discussed earlier. And when we discuss network, normally we discuss this one mechanism, what we call CSMA CD. CSMA CD. carrier sends multiple access /CD collision detect. What it means? It's actually a mechanism being used to send and receive messages. Carrier sends multiple access / collision detect. We learned this during the diploma level. That means the sender will so-called sense the network, whether the network is busy or free. Sometimes we do call listen before talk, or listen before send. That means the sender will check the network, whether the network is free or busy. If the network is busy, the sender will wait for a couple of seconds or nanosecond to send, or millisecond to send the data. If the network or the sender detect the network is not busy, free, no traffic, then the sender will send the data. So this is what we call carrier sense. It sends the network, like it checks the network whether the network is busy or free. It's same like when we want to balik kampung, we check, hey, how's the traffic? Is the traffic okay? What time shall we start our travel? What time we can expect to reach? You do that kind of calculation. Or nowadays it's very easy. You open up your GPS Waze and you just check. Within second, you know how many minutes it takes to reach your destination. That's how. In fact, that technology is all comes from here. This CSMA /CD. CD is collision detect. What it means, collision detect. For example, your GPS will tell you there is an accident, there is a roadblock, there is a policeman stopping all the cars, or there is a jam. Now, that is collision, so-called collision detect. All that will be detected by your network through the satellite GPS, and it downloads to your handheld device, to your phone, so that you can see all that visible to you. All that technology once upon a time was used by company like Cisco and IBM and Motorola for very high level operation in the war, in the military, in networking. But today it's easily available on your handphone for almost free. And we are using it without understanding it, how it works. So all this technology behind your GPS or Google Map, it's all started from here. Carrier sends multiple access / collision detect, CD, which is a very basic, popular protocol or mechanism for communication to take place. Okay, guys, I think I need to stop here. Getting too much of detail. Let me see what is the next slide. Okay, it's all diagrams. You see, if there is a jam, the system should be able to understand. And then the system will display, hey, there is a jam, then there will be a delay in transmission and so on. Okay, I don't want to go into the switch Ethernet and modern Ethernet and so on. We can discuss that next week. So take a short break before we go into our local tutor. Penang, I think you will take a break this week. Carol team, you can stay in this network. I will continue after the short break. And Subang team, go and look for your Subang tutor. Join your Subang network so that you can enjoy your local tutor with the Subang network. Before that, any question?
No question.
Okay, good.
Question.
From anyone else? Okay, this Friday, if possible, I will try to have one class in the morning because I still need to replace 1 or 2 classes. And as you all know, the exam is on the 6th December. So I have to finish all the classes by end of November. By end of November, our classes will be over, meaning we have only 2 to 3 weeks. I need to finish all. So I might give you one class this Friday. Just watch out for my notification through the WhatsApp group. Most probably is on. Unless something pops up, I might not have it or might cancel it. Otherwise, it's normal, 9 to 11. 9 to 11 Friday morning. Okay, guys, thank you.
Sir,
With that, I'll
sir?
talk to you. Yes.
Sir. So we'll be having 2 classes, sir. One this week and then another one next week.
Next week will be normal.
No. I mean the replacement class.
Replacement will be this Friday.
Oh, okay.
Friday morning, remember, we used to have class, isn't it?
Yes.
One is Tuesday,
Yeah.
normal class,
Yeah.
and my
Yeah.
replacement will be on Friday morning. 9 to 11.
Okay, sir. Okay.
All right. Okay, guys, take a short break. Cal team, I'll meet you after 10 minutes. Thank you. Bye. Stay in this network. Don't drop. We will use the same
Thank you, sir.
meeting. Yeah. Thank you.